Hi, I'm Karthik.
I'm Arvind.
I'm Rishi.
And I'm Christian.
And we are here with your solution to the network designs and baseball stadiums of Arlington, Texas, Kansas City from Missouri, and New Orleans, Louisiana. And now we'll be walking through this network design presentation and exactly on how we plan to do this.
As Karthik said, these are 3 stadiums that we will be building, and we will have a core data center in Los Angeles, California, and we'll use MEC integration in order to increase the speeds that the data is sent from this core data center to the stadium, and this will allow us to maximize on-premise and remote audience experiments through technology.
Now we know that business interests are very important to you guys at Tech Stadiums. So these are our 6 prioritized business interests. Number 1 is increased participation. Number 2 is streaming. Number 2 is connected experience. Number 4 is scalability. Number 5 is quality of experience. And number 6 is unbiased judgment.
So looking at our business interests that we just found, we came together and thought that our best network theme would be SDN, or Software Defined Networking. And what the true core of SDN is taking the control plane out of the intermediary network devices and putting them in a centralized fashion. What this would do is make it less CPU intensive for each of the network devices along the way, greatly increase scalability because there would be a centralized way of having all the control plane processes. And it would also increase operational efficiency by enabling access to network automation tools such as REST APIs or other northbound APIs such as RESTconf, NetConf, or Python, Ansible, and many more. All of this really comes down to the core fundamental truth of why we chose to use SDN, policy-based networking, where we can design the network over policies rather than mundane IP addresses and subnetting.
With these business interests and this network theme that we have of SDN, we came up with a few objectives for our network, long-term and short-term objectives. Some of these short-term objectives include a low latency for speed of our network, storage solutions for storing our data that we get from games, multi-vendor functionality, streaming so that we can stream it to the whole world and have everyone view our games. Some long-term objectives that we have are scalability with our growth of our stadium, and so we can adapt to this with growing our network as well. Upgradability, so we have the newest technology in our stadiums, redundancy and security, so that we can have we don't allow breaches into our network and have our network private and secure. So
all of that, great, amazing. How exactly do we plan this out in the WAN? The WAN architecture is as follows. As you can see here, these 3 are our different our 3 baseball stadiums in our various locations, and this is Tech Stadium's headquarters at Los Angeles, California. This will have the core data center, whereas each of the other baseball stadiums will have branch data centers. Utilizing the MEC technology that Rishi talked about earlier, it will go towards the core data center and pull the necessary software components that it needs from that and put it inside its secondary data center. What this would allow us to do is bring the information from the core data center much closer and decrease latency much more efficiently. Also, it's very key to note that the vendors on this side of the spectrum need to have access to their point of sale system on here, which is the actual internal network of the baseball stadiums. This is our extended high-level network topology. And if you look at the right side over here in the internal sector, we decided to segment each of our different endpoints into endpoint groups, where we could then assign policies based on the type of endpoint group that they were in. For example, guest users and premium guest Wi-Fi users. Well, premium guest Wi-Fi users is for the suites, whereas guest users is for just anyone who's normally there to attend the baseball game, and they'll use 5G, whereas premium guest Wi-Fi users will use Wi-Fi 6E, as mentioned before. The other endpoint groups are here as follows: the servers, operations staff, streaming, field operations. One important thing to note is that each vendor has its own endpoint group, and legacy devices do as well. But that's not all. Don't skip this slide. We still have to talk about how all the magic happens with VXLAN and integrating that with EVPN, which makes all of this work. Essentially, data traveling from one place to another happens through VXLAN tunnels, and EVPN allows taking MAC address learning outside of the data plane and bringing it into the control plane, where VXLAN can pick that up and effectively establish these tunnels across the network to wherever they need to go, allowing for security, scalability, redundancy, all of the above, and connectivity as required. In our underlay topology, here you can see that in our DMZ, we have a spinal leaf architecture because we will be implementing servers such as the streaming service and the app service, which needs to be public facing over here. Inside our internal network, we will be using a collapsed core architecture in order to effectively optimize northbound traffic. And just speaking specifically to the firewall policies, the external firewall will have specific static ports open to let in requests to the public-facing servers, whereas the internal firewall will have a policy where it denies any automatic requests coming in and only accepts new packets that have been already from a previously established connection.
In this network, we had two wireless guest networks we wanted to implement. The first one is 5G in a box, which is a private cellular network that integrates MEC, as we previously mentioned, to reduce latency in our network. And this overall reduces the footprint our network has and improves its efficiency.
For the premium suite users, we have Wi-Fi 6E, which supports 2.45 and 6 GHz, which is a wide range of connectivity support and has a great deal of flexibility whether they want long range or short range and faster access. OFDMA is a new technology that the Wi-Fi 6 spectrum released, which allows simultaneous packet transmission to multiple users at the same time. Also, target wait time reduces power consumption for the network, which is another technology that this new Wi-Fi technology enables.
In baseball right now, calls play a huge part of the game, and umpires are always flamed for not making the right calls. But right now, we would like to give our umpires the right resources in order to make these calls. And so we're going to use sensors, spider cams, and kiosks. And in this, we'll use 5G and MEC integration. And in order to do with both of these being integrated, it'll make the data computation even faster, so refs have it in real time, so they can call games really well.
Network security. This is the most important part of any network. So we will implement group policy, as we discussed earlier, with our various different endpoint groups. And we will also have NGFW, or Next Generation Firewall, which will inspect packets in a stateful manner, which will allow it to more aptly recognize network things. We will also have company-based VPN access, which will mean that each vendor on the location will be able to access the company's headquarters with an end-to-end encrypted tunnel. We will have network visibility, which means the network operations team will be able to use IPv6, an open vendor protocol, to be able to talk to be able to look at the entire network and find threats and stop them at their roots. And we'll use Cisco IC to perform profiling and posture assessments. The profiling assessments will allow us to classify users into the various different endpoint groups, and the posture assessments will allow us to check an endpoint for its different security features, and if it is not up to date in security features, we can place it into the vulnerable devices endpoint group, where it will then be prompted to update its security. And finally, the most important part of any network, we will have physical considerations, which will consist of locks on doors and security guards.
So that's great. We have a great network. Everything's great. What's next? Well, we gotta deploy it. We're going to use template-based configurations, where instead of having to manually configure each device, we can just create a template and just push it out to a bunch of devices. Zero-touch provisioning comes in handy when there's a bunch of new users coming in, didn't expect it. Well, what can we do? Plug in a new network device and it automatically grabs its configuration. All of that being said, we need a remote access solution, which we will offer through a bunch of northbound interfaces that the controller offers, all of this leading to scalability. And all of this is for streaming and the streaming clients. Since we place this in the DMZ, we can ensure that people can access the streaming service effectively. Also, we will be using IPTV Dash in order to facilitate this, as it is a codec agnostic platform, and it doesn't matter which codec to use in order to facilitate the streaming.
Now we come to everybody's favorite part, the expenses. We've categorized our financial summary in 3 different ways. Number 1 is our cost of network production, which is $2.34 million. Number 2 is the technology products for the stadium that's already there, which is $3.11 million. And lastly, the operational expenditure, $2.74 million. Most of it is resource costs, but $390K is for license costs.
But all that goes to a great network design. So thank you for listening.